Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to look at another electronic circuit. Here it's our circuit. We're creating an inverting logarithmic amplifier using this ideal op amp and just a simple transistor and resistor. You can see the relationships, and later on I'm gonna sketch the result into Excel. Okay. But before we get started, if you're new here, please give me a thumbs up, hit that subscribe button, and also the notification bell, so whenever I upload a new video, you'll be aware of it. Let's jump into it. Here, it's the question. A student attempts to construct an inverting logarithmic amplifier as illustrated in figure below. Plot V out versus V in Excel. Okay, here are some assumptions for this problem. Now, here, this is an ideal op amp. So in an ideal op amp, these two nodes are the same. So if this is ground, this is also ground, or we can call this one as virtual ground because it's not actually grounded. And the input current of op amp is 0. So this current, which is V in minus 0 divided by R1, which is this current, it goes through this transistor, this bipolar NPN transistor. So we know that in a transistor we have a relationship between the base emitter of that transistor. This is a base emitter, and this is the I collector of this transistor. What is the relationship? The relationship is exponential. I mean that I collector equals to IS times exponential VBE divided by VT. Or we can rewrite this by taking an ln from the both sides and calculate VBE. So VBE is equal to Vt ln of IC divided by IS. This is our relationship. Now, what is IC? IC is equal to V in divided by R1. You can use KCL in node X. Okay? By using KCL at node X, you can derive this equation, V in divided by R1 equals to IC. So we can substitute this in this equation and rewrite it. So VBE equals to Vt ln of, instead of IC, V in divided by R1 times IS. Now instead of VBE, what we can set that VBE here, because I'm gonna derive an equation which shows the relationship between V out and V in. So here VBE is equal to the base voltage is 0 minus the emitter voltage is actually V out. So VBE is minus V out. Now we can substitute this into this equation, and here our final result, V out equals to minus Vt ln of V in divided by R1 IS. In the last step, I just times the both sides by negative 1. So this is our final equation, and as you can see, there is a natural logarithm relationship between V out and V in. As simple as that, we can create such an amplifier by using op amp and bipolar transistor. Now, in order for you guys to get the sense about this relationship, I'm gonna plot the result into Excel, and this is another skill that I'm gonna show you in a minute. This is my Excel that I'm gonna plot the result. So this is my Excel, and I'm gonna plot this equation somehow. we need some numbers in order to do that. For example, here it's our V in. This is an amplifier to respond to some small signal model. So V in had to be small numbers like millivolt. Okay, for example, I start with 10 millivolt, 10 E minus 3, which means 10 millivolt, and the rest would be, for example, 20 milliamp. And you can just choose the both cells and continue so on, so you can see the result for that. And how about V out? In order to extract some numbers for V out, you had to use this equation in here. And what is this equation? This equation, you had to write it down like this. In this cell, use equal, then minus VT. VT is 25 millivolt, 25 E minus 3, then times ln of V in. For V in, you had to choose this cell, divided by R1 IS. R1 is 1 kilo, so 1 is cell, and then IS 5 times 10 to the power of minus 15. I can choose again division of IS, which is 5 times E minus 15. Okay, this is one way of doing this. Or you can choose the parentheses in the denominator. Both are the same. So hit enter. Sorry. I think I made a mistake in here. Let me just now I think in the division I made a mistake. Now I correct this equation. This is the final equation. Let me just rewrite it for you. Use the equal sign in here, then minus VT, which is 25 E minus 3 times ln of this is V in divided by R1, which is 1 kilo ohm, divided by IS, which is 5 E to the power of minus 15, and then close the parentheses, and this is the result for the first number. Now in order to do the same, you just click in here and drag this to the last number. Now you have all the results for V out, and now we can choose these columns in Excel and insert from plots, from charts. You can choose whatever you like, for example this one, and you can use this line chart to draw the results. And as you can see, this is the natural logarithm of V out versus V in Excel. This is the way that you can plot a result and get this feeling about the relationship between V out and V in. And you can choose something here, for example access titles. You can clarify this and use it in here. This is V in volt, and here the y-axis is V out in units of volt, V. So this is the result in Excel. I just want to show you how we can plot this. Okay guys, I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching.